Hello, welcome to the homework review for homework 4.1, Ratios with Similar Parallelograms, ACE problems 1, 3, 4, and 15 to 20. Today in class we talked about how you could use ratios of adjacent sides to determine if shapes are similar. They'd have to have corresponding ratios of, say, short side to long side or long side to short side, and their angles would have to be the same. We're practicing that for homework today. It says figures A through F are parallelograms. List all pairs of similar parallelograms. Rectangles A and B are similar since the short side to long side ratio of 2 to 4 is equivalent to 3 to 6. So A is equivalent to 2 to 4, short side 2 to 4 is equivalent to 3 to 6. 4 to 9 is not equivalent because the ratio ends up simplifying to 1 to 2, and 4 to 9 can not simplify to 1 to 2. For the parallelograms, rectangles D and F are similar because the short side to long side ratio of 2.75 to 3.5 is equivalent to the ratio of 5.5 to 7, and their corresponding angles are the same. They all are 64 degrees. So D, E, and F could have all been similar, but only D and F are because a ratio of 4.25 to 8.5 is not the same ratio. And again, we're moving on. I kind of jumped ahead. So for B, that's what you had to do. You had to find the ratio of two adjacent side lengths in one parallelogram and compare it to the ratio of the corresponding side lengths in the other parallelogram. I chose to do short side to long side. You could have picked long side to short side. As long as you're consistent, it doesn't matter. But for A and B, it's 2 to 4 and 3 to 6. So it ends up, if you're dividing those and turn them into a decimal, it's a ratio of 1/2 or 1 to 2. And then for D and F, like we said, it was 2.75 to 3.5 and 5.5 to 7. If you divide those on a calculator, you'll get 0.786, which is the same ratio. Or you can also think of them as 2 3/4 to 3.5, and 5.5 to 7, and 5.5 to 7 is just double that, so it's the same ratio. So they have the same ratio. So therefore, the ratios for A and B are equivalent, and the ratios for D and F are equivalent. For each pair of similar parallelograms, find the scale factor one shape to the other. So the scale factor from A to B is 1.5, or from B to A is 2/3. The scale factor from D to F is 2, or from F to D is 1/2. If you go up and look at that pictures, to go from A to B, you multiply it by 1.5. To go from D to F, you multiply it by 2, or vice versa, either 1/2 or 2/3. And this is an important question to understand, is explain how the information given by the scale factors is different from the information given by the ratios. And if we kind of review our numbers again, the scale factor from A to B is 1.5, which means that A to B is 1.5 times bigger than A. The ratios are 3 to 6 and 6 to 3, if you think about it the other way, depending on which way. But either way, that just talks about side lengths. So it's either twice as long as it is wide or twice as wide as it is long, depending on how you think about it. So ratio of side lengths is not really have anything to do with scale factor. The scale factor compares the corresponding sides of two shapes, while the ratio of the side lengths within a shape is compared to the ratio of the corresponding side in another shape. So let me say that again. The scale factor compares the corresponding sides of two shapes. So that's like saying the width of one to the width of the other, the height of one to the height of the other. While the ratio of the side lengths within a shape is compared to the ratio of the corresponding side lengths in another shape. So you're comparing height to width of one shape to height to width in another shape. So scale factor, you're figuring out how many times bigger. And in ratio, you're trying to just figure out what that ratio of length to width is. On the grid below, draw two similar rectangles so the scale factor from one rectangle to the other is 2.5. Label the length and width of each rectangle. So here your rectangles, what you start with really doesn't matter. You could draw any rectangle you want. You could draw a 1x2, you could draw a 2x4, you could do whatever. What matters is that your larger rectangle is 2.5 times bigger. I don't know, I just picked 4x6 because I knew that with even numbers I could double it pretty easily. So my original rectangle is 4x6. I apply my scale factor of 2.5, so 4 times 2.5 is 10, 6 times 2.5 is 15, so my new rectangle with a scale factor of 2.5 is 10 by 15. So go from 4 to 10 is 2.5, 6 to 15 is 2.5. Find the ratio of the length to the width for each of the rectangles. Oh, I just realized I did mine backwards. That's okay. We'll just fix this. Hold on. So they said to do length to width. I'm just going to think of it as short side to long side again. So for me, my example, the short side to the long side is 4 to 6 and 10 to 15, which is 2 to 3. So as long as you're consistent again, short side to long side, whatever you pick it. Draw a third rectangle that is similar to one of the rectangles in exercise 3. Find the scale factor from one rectangle to the other. So in this one, I already had a 4 by 6, I already had a 10 by 15, so I decided I would do a 2 to 3 because my height to my short side to my long side ratio is 2 to 3, so I might as well make a small 2 to 3 rectangle. So I called that C up here. And what's my scale factor? It depends which way you're going. You could go from A to C, which is going from 4 to 2 or 6 to 3, so that means your scale factor is 1/2. We could go from B to C, which is going from 10 to 2 or 15 to 3, so that scale factor is 1/5. You could go the other way. C to B is 5, C to A is 3, or 2, I'm sorry, 2. We want to do A to B because we know that A to B is 2.5 times bigger because we made it 2.5 times bigger. What's the ratio of the length to width from our new rectangle? Well, it's still 2 to 3 because I made it similar. So my short to longer side is still going to be 2 to 3 because it's similar. And whatever you made in your rectangles would be the same. What can you say about the ratio of the length of the width for the 3 rectangles? Well, they're all similar. They're similar triangles, so the length of the width, the ratio of the width to the length or short side to long side is going to be the same for all of them. So I know I kind of went through that kind of quickly. If you still have questions in class, you can ask me tomorrow. Our secret word for today will be green. Since it's St. Patrick's Day, we'll say green. And we have just a few more problems here to look at. For exercise 15 to 20, tell whether each pair of ratios is equivalent. There are a couple ways you can do it. You can divide so that you can get a decimal for each one of them, or you can just use them as fractions. So is 3 to 2 and 5 to 4 equivalent? I think of that as 3/2 and 5/4, and 3/2 is 1.5, 5/4 is 1 1/4, so no, they're not equivalent. 8 to 4 and 12 to 8. 8 to 4 is the same as 2, and 12 to 8 is not the same as 2, so no, they're not equivalent. 7 to 5 and 21 to 15, and you can simplify 21 to 15 as 7 to 5, so yes, those are equivalent. 1.5 to 0.5 and 6 to 2, yes, those both are equivalent because it's really just 3 to 1, right? So they simplify to 3 to 1. 1 to 2 and 3.5 to 6 are not equivalent. It would have to be 1 to 2 and 3.5 to 7 or 3 to 6, but so they're not equivalent. And 2 to 3 and 4 to 6 are equivalent because 2/3 is equivalent to 4/6. I guess that's it. Thank you very much.